right, lesson 6. Inductance and capacitance in AC circuits. This is where we started having fun with X of L and X of C. Okay, AC inductive resistive circuits, that means an inductor and a resistor. Capacitive resistance circuits, capacitor and a resistor. And inductors, capacitors, and resistors in the same circuit. We talked a little bit about resonance, right, power factor correctors, and converted an AC series LCR circuit to an equivalent parallel circuit. And what are the 3 things that need to be equivalent? Number 1, admittance. Number 2, impedance, and number 3, current. Okay, so reactance was the opposition to AC current. Inductors oppose a change in current. It's only present in AC circuits. Why? Well, because of the expanding and collapsing magnetic field, right? In an inductor in a DC circuit, what did we say after the fifth time constant? It was what? It was a short. So I have no opposition in a DC circuit with an inductor. Okay, after the fifth time constant, it's short. Okay, the lines of flux have expanded as much as they're going to expand, and I'm at max current. Everybody knows the symbol is X sub L. And we figured this one out. 2 pi FL is the one we always use when we're given a frequency. If given angular velocity and time, or angular velocity equals 2 pi F. Okay. 2 pi radians per rotation, right? 6.28. And frequency, how fast? Angular velocity. Okay, so we're given a frequency, we're given an inductor value, 2 pi times F times L, to get an inductive reactance of 6.28 K. Converting that into impedance, we simply put that in rectangular form, add everything up. That circuit just had an inductor, so the total impedance is going to be 6.28 K or whatever it was at positive 90 degrees. Okay, if you have a resistor, it's going to be somewhere between 0.001 all the way to 89.99. Okay. And if we know current and voltage, you can find impedance, Ohm's law, right? And you can also find the magnitude of impedance using trigonometric functions, Cartesian plane, triangles. Anything that you add, you can use a triangle. Okay? If you get stuck, by all means have at it. Use a triangle. So it's all. And if you know at least 2 sides, you can use the inverse of a trigonometric function to find the angle. Arc tangent, arc cosine, arc sine. All right. And here is using Pythagorean theorem to find the length of impedance. Again, you would use your trigonometric functions or the arc function, the inverse function, to find the angle. Current, Ohm's law. And the voltage drop across the resistor and the inductor. If you know current, it's a series circuit. Current is what? And you just multiply it by X of L and R. Okay, voltage of the resistor will be the same angle as line current. Does everybody understand why? What angles does resistance have? 0. And when you're multiplying times current, what happens to the angle in polar form when you're multiplying? You're adding. So this is the voltage of the resistor. It's going to have this angle because you're not going to add anything to it. Okay. Does everybody understand that? Here, this angle and this angle, basically what I just said, these two angles get added together. Right, the previous slide, this was R, so this was 0. But these two get added together and become this voltage angle, right? To find current's angle, I subtract the impedance angle from the voltage angle to get this angle. Everybody understand that? Okay.